Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2021 Mathematical Methods Exam 2 Northern Hemisphere multiple choice section. So yeah, let's get started. The graph below shows one circle of a circular function. Okay, find the rule for the function that could be. Okay, let's find the actual period. So 2 pi, well here n equals 1 because there's just 1. So 2 pi equals n. Which ones has 2 pi? 2 pi, 2 pi, 2 pi, these are wrong. Well, there's a translation of 1 year up. So, this one is wrong. So, it's going to be y, it has to be e. Because if it was sine, so sine will look like this, and it's just reflected, perfect. Cos, in the other hand, will look like this, and somewhere around this, and somewhere like this. Blah, blah, blah. And then if it was reflected, it would look like this, which is not how it looks over here. So yeah, easy answer. So question 2, if 3 f of x is this for x is greater than 0, then the rule could be... Okay, so does this meet this standard? So does this meet this condition? Let's try A. So 3 f of x is what? 3 times 3x, which is 6x. The other one's... So f3 of x is 3x, which is 6x. A should be your answer. I'm not going to check the other ones because I'm just going to go quick. Yeah. Question 3, the function this will have an inverse 4. Okay, I'm going to do this on calculus. So what I'm going to do is go on graphs, and I'm going to actually write the function. So x to the power 4 over 4 minus x to the power 3 over 3 minus 9 2x squared x squared plus 9x gives us this graph. So I want to find the inverse. So we need it must meet the horizontal line test. So the first one's all reals, absolutely not. So A is not your answer. B says from -3 to 1. So let me just find the minimum value over here. So -3 to 1. So if I go over here, top, look, from to 1, which is over here. Okay, -3 to 1, perfect. Yeah, it meets all the horizontal line tests. So, question 3, B should be your answer. The graph of f of x is this, and has a turning point at x equals blah, 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 and the y-intercept at y equals 9. The values of a, b, c could be y. Okay, so I'm going to do this by defining f of x, actually. So let me define this f of x over here. Wait. I know straight away that c must equal 9. Because your c value, everything, if you let, x equals 0, it just becomes c equal 9. Okay, so I can just say b and d are wrong. Okay, let's finish it. So x to the power 3 plus a times x squared plus b times x plus 9. Okay, and we get this. So, because it has a turning point at that point, so if we say we'll find the derivative of f of x, this at x equals 3, we get this. That's your gradient, and it must equal 0. Okay, this must equal 0. Okay, so does this equal? We want it to equal 0. So okay, let's try to put some values in, and if it's true, it works. So the first one is a equals -5 and b equals 3. True. Okay, that's your answer. A. Question 4, A should be your answer. Question 5, the expression log this is equivalent to... Okay, so log 3, it can be written as √5 minus log 3 q squared p. This log 3, if we put a half here, it'll be 5 minus log 3 q squared plus log 3 p, which is half log 3 5 minus 2 log 3q. minus log 3p. Which one does that look like? C looks right. Half log 3 minus 2 log 3q minus log 3. Perfect. So the sum of the first positive solutions to the equation this is what? We'll do it on a CAS. Okay. So control N this. I know we want to find solve of tan 2x equals 1, comma x. We're going to put a domain. Now, I know that, okay, it says tan 2x, so pi over 2 will be your first thing. So pi over, say pi, let's say from 0 to pi. Let's just say 0 to pi. Okay, we get 2 solutions, but we want 4 positive solutions. So it should be 2 pi here. Okay, so if we add these all together, just add these all together, 7 pi over 2. So that's D as your answer. Part of the graph of f dash of x is shown, so that's your gradient graph. Given that f of 0, so given that f of 0 equals 1, the corresponding graph would be, so when x is 0, it should equal to 1. Absolutely not A. This one looks good. This one looks good, and this one looks good. What else? Okay, straight away, we know that, let's say B is your so because it has 2 x intercepts here, it means that it must, in the normal f of x, like the actual f of x, it should have 2 turning points at 1 and 3. So here we have 1 and 2. Perfect. So this one has it. What the hell? This one looks wrong. Okay, we have 3 and 1, so we have 2 turning points. Okay, could be right. And this one, absolutely wrong. What else? What else can we take out of this? Okay, let's look at it in terms of this. So, let's say it was B first. B. So, it goes up till here. So, yep, it's positive. It goes down, so it's negative and positive. So, that looks good. Whereas this one over here, it goes negative, negative, so it should be down over here. It would have been like this. It would have been like this. So it must be B as your answer, actually. Yeah. That's not too bad, this question. Okay. B is your answer. Should be. Yep. Part of the graph of the polynomial function f is shown. The graph has turning points at these 2. So, here. 2, 2, 1, 2, 2, 1. Okay. Strictly decreasing. So it's going negative, negative from all to here. So that's good. It increases there, but it also decreases to here. So we can say, yeah, we can say that it goes from negative infinity to negative 2 root 2 union from 0 to 2 root 2, blah. Just a quick, what that gives us that. D looks like your answer. Question 9. The continuous and differentiable function has roots at x equals 1 and x equals 6, and a repeated root at x equals 4. Given that from 1 to 4 f of x is a and 4 to 6 is b, whereas where a and b are all reals, 1 to 6 f of x is equal to. So let me just sketch. So it has 1 here at 4 and at 6, but it has a repeated at that. So if we go like this, and it repeats, so it's going to go like this, and it goes like that. Okay, and we know that from, so that's 1, 4, 6. So we know that 1 to 4, so this is A, and 4 to 6 is B, and we want to find, just break this one apart. So we want to find f of x dx plus 1 to 6, 1 dx. Well, this one over here is easy because it's just A plus B. This one over here goes as x, 6 to 1, so it's 6 minus 1, 5 plus 5. A plus B plus 5. So C is your answer. Is that right? Yep. Consider the function this. The tangent to the graph of f is parallel to the line connecting the negative x-intercept and the y-intercept of f of x. Okay, let's find the, go on calculator and just let's say solve. I want to find, okay, we know, wait. We know that the y-intercept was what? So it's 0 to 5. What about our x-intercept? So for our x-intercept, what I'm going to do is go on our calculator. So solve negative x squared negative 4x plus 5 equals 0, comma x. And we get, okay, but we want the negative x-intercept. So negative 5, 0. Okay. So 0 minus 5, negative 5 minus 0, which is 1. So that is your gradient. Okay, so if we find f dash of x, which is negative 2x minus 4, and we let it equal to 1, we get negative 4 minus 1, 2x, negative 5, 2x, negative 5 on 2 equals x. B is your answer. A survey of a large random sample of people found that the approximate 95% confidence interval for the proportion of people who owned a yellow rubber duck was this. The number of people in the sample are, so your n value. What is our n value? They don't also give us our p values. So, okay, this is not too bad. So what we can do is, okay, let's go on our calculator and go on menu, algebra, solve systems of equations, and we want to find p and n. Because we don't know both of them, but we just want to find n anyway. So what I can do is, I know that the confidence interval from, so I know it's normally written as p minus, because it's 95, so it's 1.96 times the square root of p times 1 minus p n. So we put that, and that's all equal to the first value, which is 0.6229. And what I can do is copy this whole thing. And just change this to plus, and change this value, which is 0.6699. Enter. So your n value is 1,589. Oh, is that right? Oh, okay, wait. I made a mistake here. I can see. It doesn't look. It's supposed to be 9 here. Okay, we got 2185. Yep, so is your answer. A transformation that transforms the graph of y equals x. So maps means transforms the graph of this onto the graph of this. The transformation could be given as what? Okay. So what we can do is we can say y equals. Okay. First, let's say f of x. Actually, just change it to f of x. So let's say f of x equals x to the power 3 minus x. Well, this one here, let's look what we can do. Well, we can add 2. So we can say f of x plus 2, x3 minus x plus 2. And what we can do is we can dilation by parallel of 2 parallel to the y-axis. So 2f of x plus 4, which means that 2x3 minus 2x plus 4. Okay. And then what we can do is we can also a translation of 1 unit to the right. So x minus 1 plus 4. So that's, yeah, so that should give us the same. So can we see that one that looks similar to this? So first what we did was we translated 2 units. So let's just have a look. Okay. Let's try number A. So A. So it's saying x dash is equal to x plus 1. Y dash is equal to 2y plus 4. And that y dash can change to y. So it means that if we subbed it in that, we've multiplied everything by 2. So if everything gets multiplied by 2 in this, it'll be 2x3 minus 2x. And then what's happened is they plussed 4. Okay, yes. And, okay, x should equal x dash minus 1. So if you stop, okay, yes, A looks right. A is the right one. I mean, I just checked A. I just want to double check everything else. So A looks right. A just, yeah, it looks right. Let's try the other one. So just quickly, this one over here, if I said that Y, so it's saying half Y plus 4 equals Y dash. So we're saying that Y dash minus 4, 2. No, what the hell? It means that we're dividing everything, so he's wrong. This one over here is Y dash, C is Y dash, Y plus 2. Nope. Nope. And this one says E is 2Y, so Y dash is equal to 2Y plus 2. So Y dash minus 2 over 2. So multiply everything by 2, but then add 2. No, we need to add 4. Yeah, he's right. So for the function this, where x is greater or equal to 0 and k is greater than 0, the value of a of this is what? Oh, I'm going to do this on calculator actually. Just say, we can just define p of x as k times negative k times x. Okay, we get this, and we want to solve p of a equals half p of 0, comma a. We just get this. So which is, and we want k to be greater than 0. Yeah, so if k is greater than 0, makes sense. So a is positive. Which one's that? So half pi 2, so half natural log, so log e2. B is your answer, half log e2. Okay, this is a random variable, has a probability density function over this. The variance is what? Okay, not too bad. So we know the variance. So variance is actually equal to x minus, so integral from negative infinity to infinity of x minus your mean squared f of x dx. So what I can do here is I can do this. If I know for integral, let's find the mean. So from 0 to infinity for this function of, okay, so normally it's x times 0.2 times, so wait, 0.2 times e negative 0.2x. We get this, comma x. So this here is our mean. Now we have our mean. I can copy and paste this. And now we want, okay, we want x minus your mean, which is 5, squared times your f of x, which gives you 25. So A is your answer. The graphs of a function f and g are shown below. Both functions have the same domain. So yep, we can see that. Where b is greater than 0, okay, and the same average value, and have the same average value. So the value of b what? Well, we know the average value is normally written as what? Like 1 over b integral, so the area, it means just the area. So let's try to find the area of this first. It's a triangle, so it'll be half b 2b, which is b squared, so we can put b squared, that's your area, should equal to, again, half 1 over b, because remember, it's normally when you write it, it's 1 over b minus 0, blah blah blah. It's just 1 over b for this one. What's the area of this one? Well, it's just ab. So b equals 8. So D is your answer. In a particular city, it is known that 70% of all adults get their cut every month. A random sample of 720 adults from this city is selected. From this, find the probability. So we want to find the probability that the proportion, so P dot, of adults who get their haircut is greater than this. So greater than 0.72. Alright, so we know that P naught is equal to x over n. So it means that to find x, 720 times 0.72. So on a calculator, 720 times 0.72. We get 518. So x is 518.4. So you can rewrite it as x is greater than 518.4, and that is easy. So go on menu, go on probability distributions, go on binary CDF. Number of trials is 720. Probability of success is 0.7. lower bound is 518.4. Your upper bound is 720. Enter. We get 0.1187. C looks right. Part of the graph of the function f is shown. The smallest positive x-intercept of the graph is at A. The horizontal line tangent to f at the local minimum is B. Okay. The shaded area is bounded by the graph of f, the axis, and the y. And the graph f of B. The area of the graph. Area. So we want the positive area. Okay, so I know that this triangle over here, if I find the area of this triangle, which is what? So I know this is B over here, so distance is B times F on B. Remember, okay, so that's the area. And what we can do is we can find the area integral, so minus it, minus this area from it. So we can minus this, so minus integral from A to B, f of x dx. Because these are all at the bottom of the x-axis means that the area would be negative. So what we just want to do is we want to multiply all of this by negative, which will mean that A on B, f of x dx minus B FB. Looks like easier answer for this one. Is that right? Yep, looks like. Given that, okay, ddx is that. Okay, this is like integration by recognition. So, what I want to do is x sine x. So I want to find this. So I know x sine x would be ddx x cos x minus. If I bring, what am I doing? Okay, wait. What have I done here? So x sine x is, wait, let me take this, bring this over here. It will be, cos x, minus this, okay. And I want to find the integral, so it will be in that the integral of cos x, this ddx will cancel out with the integral, so it'll be x cos x. And that's basically dx over there. So that is looks like your answer for this one. There, right? Okay. Yep. A cubic polynomial function has roots at x equals 1. So roots at x equals 3 only. But it's a cubic. Okay. So it has to have a repeated root at one of those places. And its graph has a y-intercept at this. Which of the following statement must be true about the function of g, where g is this, the square root of x? Okay, I'll be honest, to do this question, I'm going to do the best, easiest way. So what I'm going to do is first really draw a graph. So let's say the repeated root was this over here. So we have 1 here and 3 over here. And let's say the repeated root was 3. So it would be like this, like that, and like that. But we want y-intercept to be 3, so it needs to be positive, so no. So what about if our repeated root was on the x set, number 1, so it would be like this. It'll be like this. Again, no. So that means it must be negative, the graph must be negative. So let's try again at 3, repeated root, so it'll be like this. Aha! Okay, so we can make an equation. Let's just make an equation. Let's say that, because we know, so x minus 3 must be squared, and x minus 1. And it is a negative, so we put a negative here. And, okay, what's the y-intercept? So if we sub in 0 to all of them, it's 9. That's the answer. But we want it to be 3, so we're going to translate it 6 down units, so it's minus 6. Let's just have this. Go on your calculator now, and what we want to find is the square root of this function. Squared x minus 1 minus 6. Okay, we get this graph over here. So the first question tells us, which of the following statements must be true about the function? The function g has a local maximum at x equals 2. Nope. X equals 2, there's nothing. At g, 2 equals 1. Nope. The domain of g does not include the interval 1 to 3. 1 to 3. Okay, wait. The domain of g does not include the interval. Wait, the domain of g does not include the interval 1 to 3. Could be true. The domain of g includes the interval 1 to 3. Nope. And the last one is the domain of g does not include the interval 3 to infinity. So 3 to infinity. Okay. What can I do here? It can only be C or E here. The domain of g does not include the interval 1 to 3 or does not include 3 to infinity. I just want to have a look. Zoom out, fit. And okay, so it's a, okay. Alright. 1 to 3, so it would never include here, and we're saying from 1 to 3. Alright, so, okay. What we can do is, let's try another function that's similar to this. So, just retry another function. So, I know for a fact, at least we eliminated some stuff. We know it's not A and it's not B. It's also not D. At least we can try to. Okay, what about this graph? What about if we make the repeated root at 1? So let's try that. Does that still work? Okay, so we go like this. Like this. Aha! So it still works. At 1, 3. So we can write this as x minus 3, x minus 1 squared. 0, if we put 0, or 3. So we want to, okay, yeah, this one, wait, this one has y equals 3. This is the perfect. This is the perfect actually because it has y equals 3. So wait. If I can take this over here, so it's negative x minus 3, x minus 1 squared. Okay, oh my god, here's the perfect graph. So, the domain of G does not include, yes it does, 1 to 3, it includes it. So no, the domain of G does not include from 3 to infinity. Absolutely, E is your answer. Wow. So okay, it could have been those two, but yeah, at least we've done the second graph, which helped us. The probability distribution for the discrete random variable where B is this and that. Okay, the value B is, okay, this is a typical question. So let's add them all up and let them equal to 1. So go on our calculator and say, control N this actually. Okay, and what we want is addition of all of them. So 4 over 5 plus 1 over 5. Oh, sorry, 1 over 10. 1 over 10 minus B to the power 3 plus 15 B squared minus 2 50 plus 9 B plus 5 50 equals 1. It must equal to 1. So if we solve your answer, comma B, it gives us all of these solutions. It gives us 3. Okay. Well, to actually check which one's right, what I'm going to do is, I'm going to take this, and okay, this here, if we sub in this value of B, this first value of B, it must be positive. Because that probability must be positive. It cannot be in. Okay, that's good. Let's try the next one. So, take that off, try the next one. Okay, still good. Oops. And let's try this one over here. Aha! Half is wrong. So, at least we can take that off. Let's try on another function. I just want to bring this over down here. And let's try now this function over here. Okay. So, it can only be these two. So, okay, that's good. Okay, so it can only be negative 2 over 5, which is What is negative 2 over 4? Wait. Alright. Okay, negative 0.4. So A is your answer. Okay, that'll be it, guys. Thank you guys for watching. I hope these questions are right. I'm not too sure, but if some of the questions are not right, please make sure to tell me. Make sure to link it down in the description. And yeah, I hope you guys enjoyed this video, and if it helped you, please make sure to like and subscribe. I'll be making more videos like this, so yes, if you want to be up, keeping up to date, so yeah, make sure to subscribe and turn on your notifications. Have a good day, guys, and take care of yourselves. Bye bye.